Hi, and welcome to Complex Numbers, Day 3. So today we're going to be talking a little bit about using the quadratic formula and that value that's underneath the radical. The expression under the radical in the quadratic formula, which is the b squared minus 4ac, is called the discriminant. And the discriminant is used for many different things, and it tells us some things about our graph, and that's what we're going to be talking about today. So we're going to use the quadratic formula to to solve the following equations and then calculate the discriminant for each equation. So for A, if we're using the quadratic formula, let me write it up here again in case you forgot it. Okay. And just as a reminder, all the equations are in the form of ax squared plus bx plus c equals 0. Just so you can remember we got the a, b, and c. So in this first problem, a is 1, b is 0, and c is negative 9. So when I substitute in to the formula, I will get negative b, which is 0, plus or minus the square root of b squared, which is 0, minus 4 times a is 1, and c is negative 9, all over 2 times 1. So x equals plus or minus the square root of 0 plus 36 all over 2. So x excuse me, is equal to plus or minus the square root of 36 divided by 2. So x is equal to plus or minus the square root of 36 is 6 divided by 2. So x is equal to plus or minus 3. So the discriminant itself is just the value underneath the radical. So the b squared minus 4ac is equal to the discriminant, and in this case it was 0 minus 4 times 1 times negative 9. So this is 36 equals the discriminant. For the next problem here, I have x squared minus 6x plus 9. So a is 1, b is negative 6, and c is 9. So when I substitute in, I'll have x equals negative b, so negative negative 6 is a positive 6, plus or minus the square root of negative 6 squared is 36, minus 4 times a is 1, times c is 9, all over 2 times a, which is 1. So x equals 6 plus or minus the square root of 36 minus 36 all over 2. So x is equal to 6 plus or minus the square root of 0 over 2. So x is equal to 6 over 2. So x is equal to 3. My discriminant in this case was equal to 0 because that was the value underneath my radical. For x squared plus 9. A is 1, b is 0, c is positive 9 this time. So x equals negative b, so it's 0 plus or minus the square root of 0 squared, which is 0, minus 4 times 1 times 9 all over 2 times 1. So x equals 0 plus or minus the square root of negative 36 over 2. So x is equal to plus or minus the square root of negative 36 over 2. And yesterday we learned that the square root of negative 1 was I. So this is just like saying negative 1 times 36, and the square root of negative 1 is I, and the square root of 36 is 6. So we're going to say plus or minus 6I over 2. So x is equal to plus or minus 3I. And my discriminant in this case was negative 36. So how does the value of the discriminant for each equation relate to the number of solutions we found? So if the discriminant is negative, we have complex solutions. If the discriminant is 0, we have one real solution. And if the discriminant is positive, we have two real solutions. All right, moving on. That's something that's kind of important that you need to know. So consider the equation 3x plus x squared equals negative 7. What does the value of the discriminant tell us about the number of solutions to this equation? First thing we have to do is get it into a x squared plus bx plus c equals 0 form. Get it in standard form. So I'm going to rewrite it as x squared plus 3x, and then add the 7, so plus 7 equals 0. So a is 1, b is 3, c is 7. So the discriminant is equal to b squared, so it's 9, minus 4 times 1 times 7. So it's 9 minus 28. Which means my answer is negative 19. So if my answer is negative 19, I have how many solutions? Well, in this case, I have complex solutions because it's negative. So I have two complex solutions. Complex solutions always come as a pair, and they always come as a conjugate pair. And I'll show you what that means when we actually solve it in the next step here. So solve the equation. Does the number of solutions match the information provided by the discriminant? Explain. All right, so we have x equals negative b, so negative 3 plus or minus the square root of b squared, which is 9, minus 4 times 1 times 7, all over 2 times 1. So x equals to negative 3 plus or minus the square root of 9 minus 28 over 2. So x equals negative 3 plus or minus square root of negative 28 over 2. So x is equal to negative 3 plus or minus, this is negative 4 times 7. So it becomes 2I radical 7 all over 2. Alright, we need to take a step back here. I didn't actually subtract in this step. That should be negative 19. So I don't actually have to do that. And let me rewrite my answer as x equals negative 3 plus or minus the square root of negative 19 all over 2. So my two actual, simplify it a little bit more. It's negative 3 plus or minus, take the negative out of the radical because that's one of those things we can't leave. We have to simplify it. So it's I radical 19 over 2. And to rewrite it as the two solutions, it would be x equals negative 3 plus I radical 19 over 2. And x equals negative 3 minus I radical 19 over 2. So those are my two complex solutions. Compute the value of the discriminant of the quadratic equation in each part. Use the value of the discriminant to predict the number and the type of solutions. Find all real and complex solutions. So let's see how many we have here. All right, so let's find the discriminant here. A is 1, B is 2, C is 1. So the discriminant is equal to b squared, so 4 minus 4 times a is 1 times c is 1. So the discriminant here is 4 minus 4. So the discriminant is 0. So if my discriminant is 0, I have only one real root. And then you'd use the quadratic formula. So we're going to kind of modify this. So negative b, so being negative 2 plus or minus. We know that the discriminant is 0, so we'll just plug it in there over 2. So x is equal to negative 2 plus or minus 0 over 2. So x equals negative 2 over 2. So x equals negative 1. You try for B. For C, A is 9, B is negative 4, and C is negative 14. So for the discriminant, b squared is going to be 16 minus 4 times a times c. So it's 16, and that's going to be plus 504. And multiply it out. So 520 is my discriminant. So to solve this, x equals negative b, so it'll be 4, plus or minus the square root of 520, because that's my discriminant, divided by 2 times a, which is 9. So x equals 4 plus or minus 520 is 4 times 130. So it would be 2 radical 520, or sorry, 130 all over 18. So x equals 4 plus or minus 2 radical 130 all over 18. 4, 2, and 18 all have a 2 in common. So it would be 2 plus or minus radical 130 over 9 for the answers. And we'd have 2 real roots. Forgot to answer that with the discriminant. It's a positive number. So you try D. So for E, get it into standard form. So 2x squared minus x, not plus x, plus 5 equals 0. So A is 2, B is negative 1, C is 5. So my discriminant is b squared, so it's 1 minus 4 times A, which is 2, times C, which is 5. 1 minus 20, so my discriminant is negative 19, so I have two complex solutions. So if I substitute in my formula, x equals negative b, so 1 plus or minus the square root of negative 19 divided by 2 times 2, so x equals 1 plus or minus I radical 19 over 4. And those are my two equations. Let's see, did I do that right? Let me double check here. Alright, sorry guys, this should be a 2 here. So instead of 20, it would be 40. So instead of 19, it would be negative 39. So just change that to a 3. Everything else is the same. So again, you try the next one. Main ideas that we're really working with here is the discriminant, and this is kind of what stands out to me as one of the more important things that you need to take away from this lesson. It's just the discriminant and what it tells you about the roots of your equation. That's it. We will discuss this more in class tomorrow.